Second part, we done in our last video the solution of Liverpool office. Liverpool office is done, we have done that, but the problem is it took so long. Yes, it took so much time, and because we're looking for answer the subnetting questions in 30 seconds for the Cisco exam, we must improve our technique, and that's why here we are on the second task. The second task says Manchester office. Manchester office needs 4 networks and at least minimum of 40 hosts per network. So one thing I'm going to draw again here is the bit number and the networks that I can build. Network. And this is the most important part, guys. This is the key of for our success. We saw on the previous video that 1 bit builds, that's our wish, builds 2 networks, and now we're gonna have a look that 2 bits will build 4 networks. But how 2 bits build 4 network? We're gonna increase our network part, our network section in 2 bits, so that's the network. So that's why we're decreasing, we're reducing the size of the host section. What that means that more networks I can create, less hosts I can have per network. So increasing the size in 2, what can I do basing on the previous video? I can starting with the zeros and ones. I can do it like this. Let's say 0, 0, that's the first sequence, and then I turn on the 64 bits and turn off the 128 bit, and then I do the opposite around. 128 is on and the 64 is off, and then I will turn on the 2 bits. So I got all the possible sequences in there, which means that's the network 0, that's the network 64. Why? Because the bit 64 is turned on, and the third one, the bit 128 plus 0, it's turned on, so it's a 128 value, and the last one is the 128 plus 64. So the 128 plus 64 gives me 192. So these are the networks that I'm gonna build. The 192.168.20.0, 20.64, 20.128, and 20.192. So these are the networks that I'm looking for. But if you pay attention, let's go for the first tip in here. If we're looking at what's in common from the first example and the second example. The first example, we used to need 2 networks, and our first network was 0, and our second network was 128. So if we look in these numbers in here, these networks increasing at the value as 128. If you look in these networks in here, these networks increasing at the value as 64. What's the relation between them? The relation was, at the previous example, our boundary was in here. So how many bits do you talk? We talk 1 bit. So 1 bit builds 2 networks. What's the value of our last bit? So our last bit in here, the value is 128. So that's why our networks have increments of 128. Our last bit now is 64. That's why our networks have an increment of 64. So guess what? Our next example, we're gonna have the increments of 32. And that never ever gets wrong. It's always right. So let's do this. On this section, we're looking for 4 networks. Because we're looking for 4 networks, we're gonna need 4 bits, sorry, 4 networks, we're gonna need 2 bits. So that's the 2 bits. I'm gonna make a boundary in here just to make a visualization more easy. And because my last bit is a 64, I don't need to count the zeros and ones, because from this example here is really easy. But can you imagine I'm working on this bit in here and doing all the zeros and one all the way down in here? First of all, it's really easy to make a mistake. And secondly, it's gonna take so much time, and we don't have time for the Cisco exam, and especially for the real life, for the real engineer. We don't want to spend hours and or minutes and minutes and minutes doing the subnetting. And this is a class C, especially have a look on the class B. Class B we got 16 bits, so that's getting worse. So the reason I'm saying that is we have to use this tip to make our networks a bit faster. So I'm looking for 4 networks. How many bits do I need? 2 bits. So that's the 2 bits. I will make my boundary line in here. And from this boundary, because the bit value is a 64, I will start from 0. So my first network is 0. My second network is plus 64. My third network is plus 64, which gives me 128. And the fourth network is 192. And the fifth network is a 192 plus 64, which gives me 256. But hold on, 256 does exist. So I will take this one off, and there we go. I got my 4 networks. Because I got my 4 networks, I will build my network table, okay, with 1, 2, 3, and 4. I'm looking for the first host, the last host, and the broadcast address. So I'm looking for first host, last host, and broadcast address. And this is the network itself. So let's work on that. The first network, 192.168.20.0. The second network, 20.64. The third network, 20.128. And the fourth network, 20.192. That's the 4 networks that we got. That's the 4 networks that we need for Manchester. But now let's move for the first host. As we saw on the previous video, the first network was always the first host was always the network plus 1. Network plus 1. So in here we're gonna do the same, but a bit faster. So the tip in here is the first column you're gonna fill in is the first host. So the first host, it's the network plus 1. So the first host in here is 192.168.20.1, 20.65, 20.128, sorry, 129, and 20.193. That's the first host. The broadcast address, it's the second column that we're gonna fill in, and there is a trick for that one as well. To find out really fast the broadcast address is just looking for the next network and do -1. So the next network, 64 minus 1, 63. 128 minus 1, 127. 192 minus 1, 191. And remember the last one in here, the one which does exist, the 256, minus 1, 255. Okay, this one does exist. The last one in here, it's the last host. So the last host, it's always the broadcast minus 1, which is .62, .126, .190, and .254. All done. So I got the network 192.168.1.0. Let me leave this 20s in here. Let me leave this 20s in here. There we go. So the first network is going from 192.168.20.0, which is the network itself. 192.168.20.1 is the first host, and you can use hosts up to .62, and the broadcast address of this network is .63. So 1, 2, 3, 4 networks. We're looking for 4 networks. We're looking for 40 hosts, and we got a maximum of 62 hosts. So the 40 hosts is okay. Problem is solved. What about the subnet mask? The subnet mask, I got another one in here. That's really cool. The subnet mask is all bits turned on, yeah? So 255.255.255. The first 3 octets are network. And from the fourth octet, the first 2 bits, they are turned on because they remain from the network portion. So what's my subnet mask? The subnet mask, it's 128 plus 64, which is the 192. But check this out. The last network is also 192. So write this down. The last network, always it's gonna be your subnet mask. Never ever get different. Never ever. So the subnet mask, the last network, it's always the subnet mask. That's one of the ways you can verify if your math, if your calculations in here are okay. Right? Now let me tell another secret in here. Because our last bit is a 64, we saw our network increase 64 by 64. Check the first host, 64 by 64. Check the last host, which is the same, and check the broadcast address. Increases by 64 and 64. What that means? It means that if you make a mistake in here on the bit number, you blow all of the work in here. If you make a mistake in the beginning, you're never ever gonna fix your subnetting, and you're gonna get wrong results. But if you do this one right, and you're looking for the magic number, and my magic number in here is the last bit of the network, is this guy in here, the other part becomes so easy. So I'm really looking for the next video, and on the next video, the third one and the last one in here, we're gonna solve the London office, which is bigger than the other two, but we got the techniques to make that subnet in 30 seconds. Okay? So I'm looking forward for the next video, and I see you there.